The National Weather Service has issued a tornado.
It was a stormy and deadly spring day across the Deep South.
So through the 24-hour loop here, almost 200 tornadoes had occurred, and unfortunately over 315 fatalities. Why? Why so many fatalities? Why so much destruction?
Scientists at the University of Oklahoma, smack in the middle of Tornado Alley, are looking for better ways to predict them. Why do they form in some storms, but not in others?
You're going to see a really strong drop in pressure at the exact same time that you see a strong increase in vorticity, which is the area of instantaneous spin, and that confirms that there was a tornado there.
With support from the National Science Foundation, computer scientist Amy McGovern is working with meteorologists to better model tornado formation. They don't just study real storms, they create supercomputer simulations to analyze how constantly changing storm components interact.
The problem is that if you need to understand the atmosphere, there are a whole lot of other variables out there. There's pressure, there's temperature, and none of the radars or none of the current sensing instruments can get that at the resolution that we really need to fundamentally understand the tornadoes.
McGovern combs through vast amounts of weather data, looking for patterns that might be harbingers of a twister in the making.
What we're doing with our simulations is actually being able to sense all of these fundamental variables every 50 meters.
The goal? Instead of tornado warnings based on radar or a visual sighting, someday highly precise alerts could be issued based on a numerical forecast model.
It's a game changer, complete game changer. So radar leaves off basically with detecting something that's already present. The numerical model gives us the opportunity to actually project it and predict it far in advance. If it works, it will give us the promise of actually predicting a tornado maybe 1 to 2 hours in advance.
McGovern says the key to the success of any next-generation system will be gaining the trust of meteorologists who communicate life and death warnings to the public.
I can see it has to be really easy to use, and I have to understand it deeply. They don't want something that just says, here's the probability.
Harnessing supercomputers to better understand tornadoes. The more we know, the better. Lives are on the line. For Science Nation, I'm Miles O'Brien.